Bear with me, I'm just setting up the audio. Okay. So, hello, I'm going to be showing you how to convert an NFA to a DFA using subset construction. So this is a random NFA I've built up using alpha, beta, and C. This is just a random one I've made up. And as you can see, this is a non-deterministic graph. Because at this point, and I forgot to make this a final position. There we go. Because at this point and this point, you can use multiple versions of alpha. So if you're given the transition alpha at this point and this point, you can end up here or you can end up there, which makes it a non-deterministic graph. So what we need to do is we need to use subset construction to convert this into a deterministic graph. Now what we do is so for example, this is Q0, this is Q3, this is Q2, and this is Q1. This one is Q3, and this one is Q1, because of no particular reason. Again, I've made this one up. It is completely unique. Right? So what we're going to be doing is we're going to be first examining where this can take you. So at position Q0, using our subset construction, what we have to do is we have to first map them out. So using alpha at Q0, we can travel to Q0 via this one. So I write that down. And I can also travel to Q3, which is right there. So you can see, I've just written it right in there. Now, what I want to do is I want to carry on. Now, if I check on the beta and the C part of it, at Q0, using beta and C, I cannot travel to anywhere. So here, I use the nothing notation, which I believe is Greek theta, but I'm not sure. And I just carry this method through with Q3, Q2, and Q1. So at Q3, using alpha, I can travel to nowhere. Using beta, I can travel to Q2. So I write Q2. And using C, I can travel to nowhere. So this is the entire set for Q3. Then at Q2, I can travel nowhere using alpha. I can travel nowhere using beta. But I can travel to Q1 at C. So that is the only construction we need there. And at Q1, using alpha, I can travel to two positions. I can travel back to Q1, or I can travel to Q3. And again, using beta and C, I can't travel to anywhere. So we've mapped out this DFA, right? Now, if you were ever to, in say coursework, draw this out, you'd have to draw a second table again, but with combinations. Now, typically, there's you have to combine every single point of this to cover every single possible combination. But here we can cheat a bit, because if you cover every combination, which would include Q0, Q1, Q0, Q2, Q0, Q3, and every other possible combination with regard to this entire NFA, you just essentially come up with 2 to the power of n, which is n being the number of nodes or states that you have. Now, if I have 4 states, that gives me 2 to the power of 4, which is 16. I'd have to write 16 bits out. But what you can do now is you can cheat a little bit. And you see these states which are doubled here and here. These are the only actual states that we need to account for. So what we can do is we can either draw another graph, which I do recommend doing, as if you were ever doing a bit of coursework, this would be the way to go. But what I'm going to do is I'm just going to extend what I currently have. Just about that much. I'm just going to across. Now, as you can see, I have Q0 and Q3 together here. So I'm going to write Q0, Q3, and I'm going to leave out the comma because this is now a state. Also, a little thing that possible examiners would like you to do is for you to indicate the initial state and the final state, and in this case it is Q1. So sometimes people initiate through a star, which is shown like so. However, this doesn't always work, and so you can literally just write final next to it if that's your preference. I'm going to be using the little star right there. Just want to, hopefully you guys can see this. So now what I'm going to do is using Q0 and Q3 and Q1 and Q3, I'm going to solve for the rest of this. Now, as these two states are combined versions of this, what we're going to be doing is we're going to be combining both. So in Q0 and Q3, I combined both of their sets that they can travel to. So, for example, in Q0, I could not travel anywhere with beta. But using Q3, I could travel using beta to Q2. That means when I have Q0, Q3, I can now put down traveling via beta. I travel to Q2. And again, with C, I cannot travel anywhere. And with traveling via Q0, Q3, I combine the two, and I can travel back round to Q0, Q3. As you can see there. And using Q1, which is here, and Q3, which is there, I can travel to Q2 via beta, and I can travel to Q1, Q3, which is circles back to itself. Q1, Q3. Now this isn't, how should I say, officially done, but you can essentially substitute Q3 for these positions. Now I'm doing this knowing what this is going to turn out to, but again, I encourage you to draw multiple versions of the graph if you need to. Now, you can essentially cross this out because you can substitute this Q3 for the Q3s found within here and within here, so that you can have a full DFA without any irregularities. Now, if we're going to draw this out, strong glue. Don't do this at home, kids. Now I'm going to have my starting position. How should I draw this? Yeah, I'll use a marker. I'm going to have my starting position, Q0. I'm just going to indicate that there. And I'm going to have, of course, Q0, Q3. Then I'm going to have Q2. I'm of course also going to have Q1, and that's my final position. So I draw an extra circle around it. And I'm going to, of course, have Q1, Q3. Now I'm going to just quickly draw this out. And I think I may have missed one, but we'll figure this out then. So using Q0 and alpha, I travel to Q0, Q3. Okay. And using Q0, Q3, using beta, I travel to Q2. And I've just noticed using Q0, Q3, I can travel back to Q0, Q3 using alpha again. Okay. So that's just a little loop right there, which is helpful. Now this represents both Q0, so if there was a loop previously like so, this represents it looping back to here. Now I've used travel to Q2, and as we can see here, Q2 travels to Q1. So I'm just going to travel to Q1, and let's set up a C. Oh, sorry, I've forgotten this. This is a final position as well, because it contains Q1. So any position which is a final position here can be counted as a final position if it shares the same name as the final position. Well, those were just words. Okay, now I'm just going to draw out the rest of them. Now using Q0, Q3, I've done that. Now using Q1, Q3, I can travel back around to Q1, Q3 using alpha. I can also travel to Q2 using beta. Where's that green pen? Using beta. And from Q1 using alpha, I can travel to Q1, Q3. So let me just mark this out. Beta and alpha. So as you can see, this has now become a deterministic graph, as at any point, if I wanted to travel by alpha, and I travel here, I only have one possible option as per. And as you can see, this follows the exact same language in my FSA, only now it is a DFA. So yeah, that's how you do it. And hopefully if you guys ever had any coursework or homework that you needed to do and had similar structure to this, you'd be able to easily do it. However, this is called Q1, and this is called Q3. But you know, that's probably never going to happen with you guys. Till next time, good luck.